Project is on enhancing long-tail item recommendations with LLMs via distillation and alignment. So we tackle a common but often overlooked issue in recommendation systems, long-tail items. These are the less popular products that, while individually rare, actually make up most of the item pool. Since they have limited interaction data, traditional recommenders often overlook them, leading to less diverse and thus less personalized suggestions. The issue is especially critical for platforms like e-commerce and streaming, where surfacing diverse content strongly impacts user satisfaction and engagement. LLMs have shown strong promise across domains, including recommendation systems. The key idea is that they can understand both user profiles and item descriptions, even with little interaction history, making them a good fit for long-tail scenarios. However, results are mixed. Some suggest that external knowledge improves generalization, while others say that they over-rely on semantic data. Prior work mainly focused on improving accuracy with very little attention given to how to improve long-tail item recommendations. So this is something we aim to explore directly. And we will do so by adapting existing LLM-based techniques to better tackle this long-tail recommendation challenge. We also aim to balance effectiveness with efficiency to ensure our solutions are practical for real-world deployment. We used the 2018 Amazon review dataset, which originally has 8.7 million interactions and 204,000 items. And for our project, we work with a 30% subset. So each record includes both user item interaction tuples and metadata like title, descriptions, and categories. To maintain temporal consistency, we train on earlier interactions, validate on the second to last, and test on the last interaction for each user. During training, we generate 1 negative candidate per positive interaction, and for testing, we create 100 negative candidates per user, sampling based on item frequency to ensure long-tail items are included.
Here is an overview of the method we are using to tackle this problem. We have adapted the approach from ARM-RAG and trained it on a custom dataset to allow long-tail items to be predicted more frequently. This approach consists of two main components. First, the user encoder projects user embeddings from an existing collaborative filtering model into the LLM's latent space. Therefore, the user encoder captures user preference history in a format that the LLM can understand. The training process of the user encoder involves aligning the user embeddings with item text embeddings produced by the text encoder. For each user, items they interacted with are passed through the text encoder, and dot product is computed between the user embedding and item embeddings. The model is trained to maximize similarity for positive items, meaning they have a ratings of higher than 3, and minimize similarity for negative items. The text encoder uses SBIRD to embed item descriptions. To be exact, we make use of Alibaba NLP's GTE multilingual base model. It is trained alongside an item encoder that uses original item embeddings. Both embeddings are projected into a shared space via a single layer perceptron to encourage alignment. And to avoid trivial solutions, decoder networks are added as well. There is also a use of a reconstruction loss to ensure meaningful representation learning for both text and item inputs. For the inference aspect, we use the user embedding as the input, and we inject item embeddings into the model's vocabulary space. We make use of GPT-2 for this because it matches the embedding size of the user and item encoders. We then extract the logits corresponding to the item tokens and apply softmax to obtain a distribution over items. The table on the right shows sample results for one user and multiple items.
We've only been able to obtain results for our baseline, the 3 variants of DeepFM. All 3 models recommend almost all of the items, with the mean reciprocal rank indicating that on average, the relevant item is ranked 14. This is due to the low hit rate of 10 and 20%, indicating that the relevant item is not in the top 10 list. The diversity is similar across the board and indicates that on average, there are 7 categories in the top 10 items. The rank being average is highest for DeepFM, with 1 being the most popular and 10 being the least popular.
Given that our systems are able to make use of any language model, we can actually leverage the continually improving language model landscape, as well as recent reasoning models to get better recommendation systems as a whole. Furthermore, with increasing context lengths, we will be able to include a much larger pool of items to recommend, which will actually help us to include more long-tail items, and this increases the diversity of recommendations, which helps us to mitigate our issue with long-tail items. And that's all for today.